Hello viewers, in today's session we are going to discuss an important and conceptual problem from domain of functions involving a logarithmic function, right? So here in this session we are going to find out the domain of this function f of x, that is equal to 1 over 2 minus logarithm of x minus 4 to the base 3, right? So here we'll make use of some properties of exponential function, that is the general exponential function of the form a raised to x, where a is greater than 1, right? And we'll see how easily we can find out the domain of this function f of x. So here we have to find out all the values of x, or the set of all the values of x for which this function f of x is valid or defined, right? So we'll start with this term or this expression which is in the denominator. In the numerator we have 1, and in the denominator we have 2 minus logarithm of x minus 4 to the base 3, right? So the first condition is that this term, that is x minus 4, this x minus 4 should not be negative. So we should write x minus 4 must be greater than 0, because here the logarithm of negative quantities is not defined in the set of real numbers, right? So we must have this condition, that is x minus 4 should be greater than 0, or it is positive, or in other words we can say x should be greater than 4, right? So let us represent this inequality on the real number line. So here we have minus infinity, here we have plus infinity, and x greater than 4. So here we can represent 4, and here we draw a circle which implies that x is equal to 4 is not included, right? So x greater than 4 gives us this interval, that is from 4 to infinity, right? So this is the first condition to find out the domain of this function f of x, right? So now let us consider the second condition. So now in the second condition, this denominator should not be equal to 0, right? So we should not have 2 minus log of x minus 4 to the base 3 is equal to 0. So we cannot have 0 in the denominator for any value of x, right? Because in that case the function f of x is not defined if the denominator is 0. So here we have to discard all the values of x, which makes this expression is equal to 0, right? So to get all those values of x which makes this expression is equal to 0, what we will do, we'll solve this equation, right? So we can now write this equation as log of x minus 4 to the base 3 is equal to 2, right? So now to get the solution of this equation, what we will do, will make use of the definition of logarithms, right? See, we know that if we have a log of x, and here we have the base a, and here we have say y, then this expression is equivalent to this one, that is a raised to y is equal to x, right? So here the value of a is 3, and 3 is greater than 1, and for x we have x minus 4, and for y we have 2. So using this expression, we can now write 3 square is equal to x minus 4. So we have 9, and here we have x minus 4. So x is equal to 9 plus 4, that is equal to 13, right? So from this algebraic manipulation, we see that when x is equal to 13, then this expression 2 minus log of x minus 4 to the base 3 is equal to 0. So we have to discard this value of x, which is 13. So let us represent x is equal to 13 over here. So 13 lies somewhere here. So here we have x is equal to 13. So now we can easily write the domain of this function f of x from this representation, right? So from here we have x greater than 4, 4 is not included, and from here we have x is equal to 13, and x is equal to 13 should also be discarded, right? So the domain of this function, that is f of x, is now given by the interval that is first from 4 to 13. First will form this interval from 4 to 13. 4 and 13 are not included, right? And then we have the interval from 13 to infinity. So here we'll write 13 to infinity, right? And here we'll write the union. It means first we'll go from 4 to 13, and then we have the union. That it means that we have to include both these intervals, right, excluding 4 and 13. So here we have 13 to infinity. So this is the required domain of this function.